For a long time now, we've had this standard picture of the universe. And honestly, it's worked incredibly well, for the most part. But what if I told you that brand new data is revealing some major cracks in that picture? I mean, cracks so big, they could force us to rethink everything we thought we knew about the cosmos.
Well, there's a wild new theory out there asking that exact question. It's suggesting that maybe the biggest puzzles in cosmology, dark matter and dark energy, aren't actually things at all. What if they're just illusions? Illusions created because we're only seeing a tiny slice of a much, much bigger reality.
Okay, so before we can really dive into this radical new idea, we've got to get a handle on the problems it's trying to solve. So let's start with part 1, the cracks in our cosmos.
All right, first things first, let's give credit where it's due. The standard model of cosmology, you'll often hear it called lambda CDM, has been unbelievably successful. Seriously, it explains so much of what we see out there, from the afterglow of the Big Bang all the way to how galaxies clump together into massive structures.
But, and this is a big but, for all that success, some major cracks are starting to show. And these aren't small things. They're stubborn, persistent problems in the data that just refuse to go away. It's forcing scientists to ask a really tough question. Is our model just missing a few pieces, or is the whole thing just fundamentally wrong?
The biggest crack, the one everyone's talking about, is the Hubble crisis. Here's the deal. We can look at light from the early universe, run it through our models, and predict how fast the universe should be expanding today. That gives us a number, around 68. Simple enough, right? But then, when we actually go and measure the expansion rate of galaxies close to us right now, we get a totally different number. Something like 73. And here's the kicker. Those two numbers have to match. But they don't. Not even close.
And look, this isn't some small measurement error. We're talking about a disagreement at 4 to 5 sigma. Now, to give you some context, 5 sigma is the gold standard in physics. It's the level of certainty we needed to confirm the discovery of the Higgs boson. So yeah, 4 to 5 sigma, that's a huge deal. It's the universe basically screaming at us, hey, you're missing something big.
And then there's the other big crack, dark energy. Our current model basically treats it as a cosmological constant. Think of it as this fixed, unchanging energy that's just part of space itself, always pushing things apart at the same steady rate. But is it really constant? Some brand new data is starting to make us seriously question that fundamental assumption.
So, with these cracks getting bigger and bigger in the standard model, it opens the door for some pretty wild new ideas. And that brings us to part 2. A radical new picture. So let's just break down the core differences here. On one side, you've got our standard model. It starts with a Big Bang, it's got some mysterious, unknown particle for dark matter, and a constant dark energy. But on the other side, you've got this new S-matter model. And it just throws all of that out. It says our universe is a projection from a fifth dimension. Dark matter, just a gravitational ghost. And dark energy, not even a thing, just a side effect of energy flowing into our universe. I mean, it is a completely different way of looking at, everything.
This really gets to the heart of the paradigm shift. This new framework says our universe isn't some self-contained snow globe that just got shaken up once at the Big Bang and left alone. No. Instead, it suggests we live in an open system, one that's constantly exchanging energy with a higher dimensional reality.
Okay, so how is any of this supposed to actually work? I know, it sounds pretty out there. Let's get into the mechanics in part 3, the universe's hidden engine.
All right, first things first, forget everything you've seen in sci-fi movies about a fifth dimension. This isn't some physical place you can fly a spaceship to. In this model, it's described more like a timeless, infinite reservoir of pure potential, almost like the universe's source code, where our 4D reality is being constantly written or rendered from.
So the whole theory is built around this idea of a constant cosmic cycle. It goes something like this. Step 1. Energy flows into our universe from this fifth dimension, and it comes in through the emptiest parts of space, the big cosmic voids. Step 2, this flood of new energy actually stretches space-time itself, and that's the effect we observe and call dark energy. Then, this energy clumps together to form all the stuff we see, matter, galaxies, stars. And finally, the cycle completes when the densest stuff in our universe, like what you'd find in a black hole, actually flows back out of our reality.
This completely flips our view on two of the most mysterious parts of the cosmos, voids and black holes. In this model, they're two sides of the same coin. Voids aren't truly empty. They're the cosmic faucets, pouring energy in from that higher dimension. And black holes? They're not just cosmic dead ends. They're the cosmic drains, where matter and energy flow back out.
I know, this all sounds incredibly wild.
But here's where it gets really interesting. The people behind this model claim there's actual brand new evidence that supports it. So let's check that out in Part 4, Data from the Darkness.
The evidence they're pointing to comes from this amazing project called DESI, the Dark Energy Spectroscopic Instrument. It's been mapping millions upon millions of galaxies, and its latest results are showing, well, something kind of strange, something that really doesn't fit neatly into our standard picture of the cosmos.
And this chart really shows you the problem. See, the standard model, lambda CDM, predicts that the strength of dark energy should be this one perfect constant number. But the new DESI data, it's pointing to a different value. And that difference is big enough, statistically, to make us think maybe dark energy isn't constant at all. Maybe it's evolving over time.
And this is the kicker. The author of this S-matter model is basically saying, see, I told you so. This evolving dark energy is exactly what their hydraulic theory predicts. They're claiming this new data pretty much falsifies the old idea of a constant and, of course, supports their alternative. In other words, the theory predicted this strange behavior before we even saw it.
So what about that Hubble crisis we talked about? Well, this model offers a really elegant solution for that, too. It proposes the expansion rate isn't one universal number. Nope, it just depends on where you are. In those vast, empty voids where new energy is flowing in, space expands faster. Near dense galaxy clusters, it expands slower. So the reason our local measurement seems so high? According to this model, it's because we just happen to live in a relatively empty patch of the cosmos.
So, where do we go from here? A wild theory is one thing, but for it to be real science, you've got to be able to test it. And that brings us to our final section, the next cosmic test.
And this is absolutely crucial. This isn't just some philosophy. It's testable science. The S-matter model makes concrete, falsifiable predictions. For instance, it predicts that cosmic voids should bend light in unexpected ways. It says we should be able to find clouds of brand new, pristine hydrogen just forming in deep space. And the big one, it predicts we can directly measure a faster expansion rate inside voids compared to the space near galaxy clusters. These are things we can actually go out and look for, which means we can prove this theory right or wrong.
So after all that, what's the ultimate takeaway here? Well, if this new model is even partly right, it suggests our universe isn't a clockwork machine, wound up once and slowly running down. Instead, it might be much more like a living ecosystem in a constant state of flow and regeneration.
And this all leads to the ultimate question this theory forces us to confront. Is our universe a finite object, a self-contained thing that had a beginning and will have an end? Or is it just one temporary expression of an infinite, ongoing process? That's the thought I'll leave you with.